All right, let's jump right in. Today, we're going to unpack the incredible and honestly often overlooked story that's hidden right inside your own throat.
Have you really listened? Not just to the words you're saying, but to the sound itself. It's the one thing we hear all day, every day, but we almost never stop to think about the actual instrument that's making the noise.
Because that sound you're making, it's basically a direct broadcast of what's happening inside your body. It is a rich, complex signal just packed with data. And that data reveals so much more than just the words. So let's dive into this.
To really understand what this signal is telling us, and especially what happens when it goes wrong, we've got to look under the hood first. How is this sound even made in the first place?
You'd think it would be simple, right? You just talk. But no, it's this incredible symphony of different systems all having to work together in perfect harmony. In fact, medical guidelines break it all down into these three core parts.
Okay, so think of it as a three-step process. First, your lungs give you the air. That's the power. Then that air rushes up through your larynx or voice box, making your vocal folds vibrate like crazy to create the raw sound. And finally, your throat, mouth, and nose shape that raw sound into actual speech. Power, sound, shape. It's that simple and, well, that incredibly complex. And this quote just brilliantly captures the magic happening right there in your larynx. A French anatomist, Antoine Ferrain, absolutely nailed this way back in the 1700s. Your vocal folds are like the strings of a guitar, vibrating to make a note. But they're powered by the air from your lungs, kind of like a flute. So it's this amazing string-wind hybrid instrument that you carry around with you everywhere you go.
But, just like any complex instrument, things can go wrong. A string can get worn out, the airflow might get messed up. So let's take a look at what happens when this intricate system gets out of tune.
The official medical term for this is dysphonia. And really, it's a catch-all for pretty much anything from a little bit of hoarseness to a serious problem with speaking. And notice, it's not just about how you sound, it's also about what you can do with your voice and even how it feels to use it.
Now, doctors have a really intuitive way of categorizing these problems. Seriously, think of it like your computer. On one hand, you have organic dysphonia. That's a hardware problem. Something is physically broken or swollen or damaged. On the other hand, you have functional dysphonia. That's a software bug. The hardware is totally fine, but the way you're using it, the programming, is off.
And these hardware problems can be all sorts of things. Stuff like nodules, which are kind of like calluses that form on your vocal folds, or just simple inflammation from being sick, all the way to more serious things like paralysis of the nerves that control the whole operation. Each one physically changes the instrument, and because of that, it changes the sound.
So, if the instrument's broken, how do you even begin to fix it? Well, it all starts with getting a really, really close look at those tiny, super fast-moving parts.
You see, the big challenge is that your vocal folds vibrate hundreds of times a second. How do you even see that? Well, with some seriously cool technology. Stroboscopy uses a flashing light, kind of like a strobe light at a concert, to create this slow-motion illusion of the vibration. High-speed video endoscopy is even wilder. It films thousands of frames every second for a true slow-mo replay. And of course, they also just listen to the sound itself, analyzing its acoustic properties with software.
But what's really fascinating here is that healing the voice isn't just about doing vocal exercises. Therapy is a holistic, whole-body thing. Why? Because everything from your posture to your breathing, even to your stress levels, has a direct physical impact on those tiny muscles that control your voice. To fix the instrument, you have to treat the whole person.
Okay, so we've covered the biology and the medicine. But there's another expert listener that's just entered the scene, the computer. So let's make a big pivot here and jump into the world of technology to see how a machine learns to hear.
How does a machine actually listen? Not just for the words, but for the health, the quality, the actual story of the voice itself.
And this is the exact question that developers and researchers are wrestling with all the time. This quote from a Reddit user just gets right to the heart of the problem. They're trying to work with audio files, and they ask, what is a feature? What is a computer actually listening for?
Well, the answer is acoustic features. A computer doesn't understand ideas like hoarseness or warmth. It needs numbers, cold, hard data. So these algorithms break down a sound wave into specific measurable things like pitch, loudness, and the texture of the sound. It's all about turning a complex sound into a simple list of numbers that a computer can actually analyze. And this isn't some niche hobby. There is an entire ecosystem of software dedicated to doing just this.
You've got tools like Praat that linguists use for super detailed scientific analysis, and then you have Python libraries like Labrosa that make it really accessible for any developer to start pulling these features out of an audio file. It's a massive growing field.
So, why are we going to all this trouble? Why teach a machine to be such a careful, meticulous listener? Well, because the payoff is huge. It's opening up completely new ways to help people in the real world. Just take a look at this number, 98.11%. What do you think that represents?
That is the incredible accuracy of an AI system built into a speech therapy app. It can listen to someone who might have a condition like aphasia after a stroke, and it can determine with near-perfect accuracy if they pronounced a word correctly or not. That means people can practice and get feedback anytime, anywhere.
And this right here is where everything comes together. This entire journey we've been on, from the pure biology to the medical devices, all the way to the computer algorithms, it's all converging on this one single idea. The sound of your voice is becoming a new kind of vital sign, almost like your heart rate or your blood pressure.
And so that leaves us with this huge, fascinating question for the future. We already know our voice carries signs of our physical health and our emotional state. So as our technology gets better and better and better at listening, what other stories, what other secrets will it find hidden in the sound?